Simple harmonic motion. Any motion whose acceleration is minus a constant times the displacement is defined as simple harmonic motion. Examples being a pendulum, a mass connected to an elastic or a spring, or an object oscillating up and down in seawater. So we use V for velocity, we use S for displacement from the equilibrium position O, we use omega for an angular velocity, A is the amplitude, this is the maximum displacement away from the equilibrium position O, and T is the periodic time, that's the time taken to complete one full oscillation. Now we can use the equations V squared equals omega squared on A squared minus S squared. Now from this we can deduce that the maximum velocity is omega times A. This happens when S is 0. So when S is 0, V squared is omega squared A squared. This means then V equals omega times A. That gives the maximum velocity. Now the acceleration equals minus a constant times the displacement. This is the definition for simple harmonic motion. Now the maximum acceleration occurs when the displacement S is A. So when this is A, then the maximum acceleration is a plus omega squared times A. T is the periodic time, and this is 2 pi over omega. Now the average speed is total distance over total time. Now the total time for one oscillation is T, and the distance travelled for one full oscillation is 4a. So the average speed is 4a all over T. So if we look at example 13.3, a particle moving with simple harmonic motion has speeds 6 meters per second and 8 meters per second when its distance from the center of oscillations are 4 meters and 3 meters respectively. We want to find the amplitude, the periodic time, the average speed, the maximum velocity, and the maximum acceleration. Now we're given 2 speeds and 2 displacements. So we're going to use the VWAS equation. So we're going to use V squared equals omega squared on A squared minus S squared. Now one condition was that when V equals 6, S was 4. So this means 6 squared is going to equal omega squared on A squared minus 4 squared. Which means 36 is omega squared on A squared minus 16. And we can label this as equation number 1. Another condition was that when V was 8, the displacement was 3. So this means 8 squared is going to equal omega squared on A squared minus 3 squared. So 64 is going to equal omega squared on A squared minus 9. And we can label that as equation number 2. So we have a system of 2 equations with 2 unknowns. And to solve these simultaneously, we can divide equation number 2 by equation number 1. So if we divide 2 by 1, 64 over 36 is going to equal omega squared on A squared minus 9 all over omega squared on A squared minus 16. Now on the right hand sides, the omega squareds cancel. On the left hand side, 64 over 36, if we divide top and bottom by 4, you get 16 over 9. So 16 over 9 is A squared minus 9 over A squared minus 16. Next of all, if we cross multiply, we're going to multiply A squared minus 16 by 16 and A squared minus 9 by 9. So if we multiply in on the left hand side by the 16 and on the right hand side by the 9, we get 16A squared minus 256 equals 9A squared minus 81. If you bring all the A squareds to the left, you get 7A squared. If you bring all the constants to the right, you get 175. Now 175 divided by 7 is 25. And if A squared is 25, this means that the amplitude A is 5 meters. So we found the amplitude. Now if we substitute that value for A into either equation 1 or equation 2, we can find out what omega is. So I'm going to use equation number 1 and I'm going to replace the amplitude A with 5. So 36 equals omega squared on 5 squared minus 16. 36 equals omega squared on 25 minus 16, which is 9. And if you divide across, 4 equals omega squared, and then omega equals 2 rads per second. Now in part 2, we're asked to find the periodic time. So T equals 2 pi over omega. So T is going to be 2 pi over 2, and that simplifies to pi seconds. In part 3, we want to calculate the average speed. So the average speed is the total distance over the total time. The total time is the periodic time, and the distance is 4a. So this is going to be 4 times 5 all over the periodic time is pi. So this works out as 20 over pi meters per second. If we want to find the maximum velocity, V max equals omega times a. Now we worked out omega is 2 and the amplitude A was 5. This means omega times A is 2 times 5, which works out as 10 meters per second. So Vmax is 10 meters per second. If we want to work out the maximum acceleration, A max equals omega squared times A. The omega value is 2, the A value is 5. This gives 2 squared by 5, and this works out as 20 meters per second squared.